Welcome, and thanks for joining us for today's webinar, the second in our three-part series on the OWASP API Top 10. If you missed last month's session, it's available on demand on our website, and a recording of today's call will be provided within 48 hours of today. So, today's webinar will focus on 5 of the top 10, with an emphasis on authentication, authorization, data exposure, and mass assignment. Our speakers need no introduction by now. We have Colin Domoney from 42Crunch, also editor of the well-known API Security.io newsletter. And in the right-hand corner, we have Philippe De Ryck, who's a web security expert and founder of Pragmatic Web Security.
Thanks very much to you, and welcome to everybody joining us again, and particularly welcome to Philippe. Good to have you again.
Yeah, absolutely. I would say thank you for having me after last session. So I think that one went pretty well. So let's see if you can keep that streak up. It's session number 2.
Yeah, and this is the session where I think things get serious. You know, we had a gentle intro last time. We're talking about the topics of everybody's favorites, the ANA, authorization and authentication. So Philippe, just start a question on this for you, just to talk through when you're going through this. People seem to get these mixed up. They get confused between the two, and they often try and use techniques and methods to use the wrong solution to solve the problem. So just bear that in mind when you're describing this. Try and make that clear what the difference is and why you think people get confused on that topic, because it's a common mistake. You know, it's something I get asked frequently. How are the two different, and when am I? What am I looking at? What tools should I be using for each?
Yeah, absolutely. And it's one of the things, actually, when I do training sessions on these topics, it's one of the very few places I like to have some definitions in place because of that confusion. Absolutely. But on the other hand, I hope that after today, things are going to be quite straightforward, and you'll have a very solid understanding of what authorization means, what authentication means, somewhat how you can do that. But of course, we only have 45 minutes, well, 42, something like that. Maybe we can go up to an hour with some Q&A and all of that. So I'm not going to be able to cover everything in depth. So what I kind of did in preparation of this webinar is I've taken some important lessons, things that I often don't find in security documentation or in things like a top 10 from OWASP, and I've tried to put them together into a story that will hopefully help you give a different perspective to the security of your APIs. And that's essentially the mission for today. And we're going to talk about 5 items of the OWASP top 10. And just to be a bit more peculiar, I've chosen not to talk about 1, 2, 3, 4, 5, but 1, 2, 3, 5, and 6, because all of these, in essence, pretty much come down to authentication authorization issues, and they're closely related. They're definitely different, of course, but they are somewhat in the same categories. And then next session, we'll talk about the remaining 5 items, which are a bit more of a heterogeneous mix of topics, and we'll discuss that in a month or in a couple of weeks. First, let me set a scene of what we're really talking about here. So we're gonna talk about API security. So hopefully that meets your expectations. Otherwise, you might have joined the wrong webinar. But we're going to talk about securing APIs, meaning that we probably have clients accessing that API, whether that's an automated client running somewhere or a client running on behalf of a user. These are actually very common use cases that we have in APIs today. And the holy grail of what we care about is authorization. Everything else is kind of not so important, because we care about authorization, because authorization is that process where we make a decision whether someone or something is allowed to perform a certain action under certain conditions. And that's making an authorization decision. And you can use access control models to do that and all of that stuff. But that's what we really care about. So what's authentication? Well, authentication comes into play the moment you want to make authorization decisions, because to make a decision if a client or if a user is allowed to do something, you probably have to know who the user is. And identification is useful, like, hey, I'm Philippe, and that's all good and fine, but you need a way to verify that. And if I'm saying I'm Philippe, you're going to verify that by having me as a user authenticate, typically against something like an authentication service, which can be some internal login endpoint or a separate service, whatever you're running, basically. So as a user, I'm going to authenticate myself. That's proving that I am the person or the entity I'm claiming to be, typically by presenting a secret or a token or something in my possession, like a YubiKey, whatever you're using for authentication. And that's essentially identifying or verifying that a party is who they claim to be. And you can do that for users or for clients. And that information is included in the request somehow, either directly when a client is involved or with some kind of session management or authentication state when the user is involved. And that's essentially what we provide to the API. Like, hey, here's a request coming from this entity. Please execute that. And API is going to be like, let's see what you're doing here. Do I allow that? Yes or no? Under which conditions? And we're going to talk about that in a bit more depth as we go on. And that's essentially what the story of today is mostly going to be about. Note that I put session management between quotes because that's a dirty term when you talk about APIs, but I'll explain that a bit later. Now, all of this is fairly abstract. It's like, oh yeah, you just authenticate somewhere and you pass something around and magic happens and you do authorization. There's a lot of custom solutions to do this, and there's nothing wrong with custom solutions, but typically when you're building a larger ecosystem, you'll come across like, how do I structure this? How do clients authenticate? How do users authenticate? And you're quickly going to end up in the world of OAuth, at least OAuth 2 and OpenID Connect. Those together offer you kind of a framework to structure a system that has to solve these responsibilities, has to address these responsibilities. And the pattern is very much the same, except that you have this authority, the authorization server, where clients and users authenticate, and that authorization server will issue access tokens, which is, we'll talk about the different formats in a bit of detail later on in this session. And that access token represents the authenticated identity, the authenticated entity, sorry, whether it's a user or the client or both. And with that access token, we can access APIs. And of course, the API is going to make authorization decisions based on that. Now, if you've worked with OAuth, and you probably know this, Colin, OAuth is like a very simple and easy framework, right? I mean, it takes like two minutes to read up about it and you're good to go. Or is it maybe a tad more complicated?
Yeah, I think my experience, I'm old enough to have worked with OWASP 1.
Oh, wow.
Yeah, and doing things on Twitter, I found it quite a hard thing to use properly. It seems simple, but then when you look under the hood, and particularly the patterns that one should use when building a solution, it's one thing to consume a service, but building that, there's a lot of options and a lot of choices. And I think people do get confused over what the right, patterns to be using are for a particular type of application.
Yeah, I like the way you put that, because that's exactly what happens with OAuth. I've been doing a lot of work on OAuth, working with companies, and they always run into the same issues, and developers often have a hard time understanding that. And I had a hard time understanding OAuth the very first time I read about it, because they talk about clients, but the client can be a backend web. It's like, what the hell is going on here? And it's very confusing. So we're not going to talk about OAuth in that much depth, but if you want to learn about OAuth and OpenID Connect, I have a free introduction course. I made this course free because I think everybody should be able to understand what this thing really is about. So if you want to learn more, head there and you can learn a bit about the details of OAuth and OpenID Connect. All right.
And I've just shared a cheat sheet that you put together that I thought was really useful. That's OWASP in one page.
Yes, that's a one-page cheat sheet on OAuth. Thank you very much for doing that. I haven't included all the references of stuff I did because, well, it would be a slide deck about, hey, I did this and this, and you can go there. Yeah, thank you for sharing that. It's absolutely very useful. But let's take a step back and let's talk about this webinar on API security. 5 of the OWASP top 10. Well, what I wanted to do before we dive into the details is kind of give you an idea of what plays where and what we're going to talk about. So we're going to talk about authorization problems, broken object level authorization and broken function level authorization. That's basically when a user is making a request to an API, and API is trying to enforce a security decision. When something goes wrong there, the API doesn't do that or doesn't do that correctly. That's when we have number 1 or number 5. Broken user authentication is kind of a weird category because in the top 10, it includes like a whole bunch of issues. It's like, oh, the user is authenticating in an unsafe way, or it's like, oh, we're managing the session wrongly, or we're doing something. There's a whole bunch of things going on. So it kind of plays on the authentication step at the bottom, and also on the interaction between a client and an API. And then we have excessive data exposure and mass assignment. Those are, if you want to call it that, those are API implementation bugs. That's something that goes wrong on the API side. It's somewhat related to authorization because we're basically either giving someone unauthorized access or leaking data. but it's not really, the solution is not an authorization solution typically. It's more a secure coding guideline to solve that problem altogether. All right, that kind of sets the scene. And before we dive in, we have a question for you where we want to see what you are already doing, and then we're going to talk specifics. All right, the question is listed in Zoom, so you can participate in the webinar, and Colin is going to take you through it.
Okay, people could pop their answers through to that. We're going to give you a moment or so to vote. Yep, perfect. So pretty good spread on that. I think the one that just stands out is that people aren't automating conformance scanning, so not verifying the APIs against contract. But other than that, I think it's a pretty fair spread and probably not too surprising. Philippe, any takeaways from that? We still rely quite heavily on manual testing for this.
We have some work to do. So I kind of like, in a sense, I like this response because it means that what I'm going to talk about is going to be really relevant for you guys. If everyone's like, we're doing API contracts and we're doing no manual testing, we have fully automated test procedures, then this would not have been that interesting. So yeah, it's a great match. Thank you for your honesty on this poll. And I think it's time to dive right in, right? So let's talk about building REST APIs. Awesome. Nothing wrong with what Olatunde wrote here in a tutorial, but this is a very common way that people learn how to build applications. Every developer starting out today will learn about REST APIs in 10 minutes, like, oh yeah, here's how you build a Node.js, and you'll end up with something like this. It's a to-do app with tasks, and you have endpoints with a get to get a task, a post to create a task, and a delete to remove a task. And that's how you learn how to build REST APIs. And there's absolutely nothing wrong with that. I learn stuff the same way when I have to dive into something new. However, what's kind of important is in 10 minutes, there's not going to be any security covered in that tutorial, which is, again, not the goal. It's absolutely fine. So whenever you learn how to build something, you're going to look at security, and you're going to find another tutorial somewhere that says like, oh, you are building a Node.js Express app. Here's how you add authentication to that specific application. Awesome. And it's going to explain that you can use middleware. And in this case, you can add that middleware to the request, requires auth. And that basically tells the application that you have to implement or be authenticated before you can access that endpoint. Makes perfect sense, right? Well, is this secure? Did we successfully secure our application? Like, I'm kind of guessing you have an idea what is going on here, Colin, right?
Yeah, absolutely. Yeah.
All right.
I mean, what are you authorizing? What are you authenticating against? Can everybody access the same point? Or, yeah, there's multiple problems with that.
Yeah, absolutely. Being authenticated is fine, but how do I know whether you have permissions to delete tasks? Maybe only certain people should be able to delete tasks, and it kind of raises questions. And that's already the first problem. So without joke, I think in your newsletter from today, I scanned through it quickly before the webinar, and I saw that the state of API security had this authentication issues like, oh yeah, there's authentication, but no authorization. Yeah. And that's definitely a significant problem in many implementations.
I mean, this thing crops up time and again on WordPress plugins. The plugin just checks, is the user authenticated? Is it known to WordPress? They don't even bother to look at the user role, and then they've got full access to the plugin ecosystem.
Yeah, very common. Absolutely. Yeah, very common. Fortunately, kind of easy to spot. I mean, if you go through your code and there's no authorization check, because this is an authentication check, like is the user authenticated, but you should probably want to have some roles to check or permissions. I'm kind of more a fan of permission-based checks because it's a bit more flexible than a role-based access control system. This permission still matches to a role behind the scenes, and it can be mapped and so on. So it's kind of the same functionality, but it's a bit cleaner to implement in code because it's closely related. So let's update our endpoint at delete. In this case, auth.has permission delete task, which implies, is the user authenticated? And if the user is authenticated, does the user have a permission to delete tasks? And that is something that is necessary on your endpoints, because you basically have to ensure that the user is allowed to delete tasks. Not every user in the system will be able to access sensitive endpoints like delete, and this kind of solves that problem. And we have fixed one of the OWASP OWASP top 10 issues, number 5, broken function level authorization. That's exactly the problem I sketched here. Checking that a user is authenticated is fine, but you need to check if a user is allowed to access specific functions or endpoints or however you want to implement that or name that in your system. That's essentially what you are required to do to implement or to avoid falling for number 5, broken function level authorization. Good job, right? Done. We followed guidelines and we now have a solid implementation. But it's not that simple, because we still have number 1. Number 1 is more severe than number 5, as you kind of got from that ranking in the top 10. And number 1 is broken object level authorization. And checking permissions is fine, but let's say Colin and I are both logged into our to-do application, and we both have permission to delete tasks. Am I allowed to delete Colin's task and Colin delete my tasks? Well, kind of depends on the authorization model you're using, but chances are that that is not going to be allowed. Chances are that I'm going to be able to allow or be allowed to delete my tasks, and Colin will be able to delete his tasks, but not the other way around. And that vulnerability, we're going to talk about that in a couple of minutes. That's basically broken object level authorization. So let me take a step back. This is good, not good enough. Let's talk about the good first. Takeaway number 1. I have a couple of takeaways throughout the presentation here. And the takeaway is to enforce authorization at the function level. So you have to apply sensible permission checks or role checks, depends on how you want to implement that. And that allows you to reject unauthorized requests before they even have to be processed. Meaning, if you, our host, is trying to delete a task and you doesn't have the permission to delete the task, then the system will be like, yeah, no, sorry, man, you're not allowed to call this endpoint. Go away. And that's essentially fixing function level authorization. All right. Let's dig a bit deeper into this. So if you look at the application, I've added a bit more endpoints. We have an endpoint to get tasks and we have an endpoint to delete tasks. The second one, maybe, at least for function level authorization. The first one, maybe not. But the real answer that I'm looking for is we don't know. We don't know because we don't really have an idea of what model the application is looking to enforce. Maybe getting tasks doesn't require any permissions at all. Maybe every authenticated user is allowed to get any tasks in the system. That kind of depends on what the application is trying to do. And that's the point I want to make here. And that's something I very often see. You'll find endpoints like this, and you don't know whether this is something intentional or an oversight. And every time you come across an endpoint like that, it's like, oh crap, you have to find someone. Hey man, is this allowed to be public? Yes or no? So if you have public endpoints, if you have endpoints in your API, routes in your APIs that allow public access, make that explicit. Because writing code like this makes it very, very clear what the intentional model is or whether there's a mistake. Because now it says, hey, getting tasks is allow public access. So anyone, well, any client, any user can access this endpoint, no questions asked. And this is very clear, very explicit in the code. And that is very important for one crucial property, and that's auditability. And that's like an intermediate takeaway I wanted to add here. Because authorization policies can only be secure if they're audited regularly. You have to audit them. You have to audit your endpoints to see, am I enforcing authorization correctly? And having these ambiguous definitions like nothing there, is that supposed to be nothing there? Or did someone forget to add something? That makes this a very, very difficult task, especially if you're doing this manually or even automated. So my advice is to always add authorization, even when there is no specific rule to check, then add a public authorizer just to make sure that this is absolutely 100% clear. Helps against issue number 1, 2, and 5, by the way, as you can see in this takeaway. All right, back to our broken problem from before. Object level access control. I can talk about this in a lot of depth, but I'm just going to give you one example of why this is OWASP top 10 issue number 1. We have our function level access control, permission to delete a task, and we have a specific piece of code that ensures that employees, in this case, can only delete tasks if they are the actual owner of that task. So that's the policy we're trying to implement. A manager would be able to delete anything, but an employee can only delete their own tasks. But that's a mess. I mean, code like this is absolutely horrible. First of all, to write. Second of all, to investigate. Third of all, to audit. This does not work very well. And policies like this are often found. I've done security reviews where the people in a meeting, I always do them in conjunction with the team, where they looked at the code and I was like, how do you check that? And they look at that and like, oh crap, you didn't. And they start writing some authorization code like on the fly in the meeting, like, yeah, let's just add this rule here. It's like, yeah, no, that's not going to work, because you have no idea. If you have dozens of endpoints, you have literally no idea how things are properly secured. And looking at code like this is absolutely impossible. You have virtually zero clue of what your actual policies that you're enforcing. And there's a reason I'm talking about that. This is normal. This is what I see quite often. I'm sure Colin sees quite often as well. And there is a better solution. And that solution is to use a policy engine. And a policy engine is something that the API refers to make authorization decisions. So basically, the API gets a request. The API is like, I don't know whether this is allowed. You know what? I'm not going to have plenty of authorization code. I'm just going to ask this policy engine, like, hey, man, I got this request to do delete task on this specific task. What do you think? And the policy engine is going to look at that. They have a policy and be like, yeah, that's allowed. Boom, allowed. And the API will allow that operation, execute it, and return a response. And if the policy engine says like, yeah, no, let's not do that, then the API will be like, sorry, I'm not doing that. And this sounds super fancy, right? It sounds like, oh my God, the whole policy engine. Well, in a simple case, that policy engine can just be a centralized class in your system. If you're building a Java app, you can have an authorization class with a bunch of rules. And guess what the auditing process becomes? The auditing process becomes, look at the authorization class to see if everything makes sense. Like, oh yeah, that's what we want to enforce. Look at your endpoints to see if you call it authorization class. Done. That's it. Of course, if you're building something a bit more complicated, then you might want to offload this into an actual service. And examples of to do that is Open Policy Agent. That's basically a very sophisticated authorization service that can handle all kinds of scenarios, from APIs, HTTP APIs, to Kubernetes things and SSH access and all of that. So it allows you to define policies. And there's a second thing rising. I didn't have the chance to dive deeply into OSO, which is a new way of getting role-based access control right. But Colin is going to tell us a bit more about that, because he actually had more time to look into OSO.
And so OSO is a really interesting product. Actually, there's an article about OSO in today's, I think in yesterday's API Security I/O, where they talk about authorization policies for microservice environments. And basically what their solution is, it's a central SDK that you can include. They've got Node, Java, .NET variants of this. And then you can express your policy in a DSL they call it Polar, which is hence the little bear. It's Polar, the language that they use, and it's it's a business level expression. So you can do things like RBAC, you can do ABAC type roles in this language, and then you just include that code into your application and let them handle those complex. You end up writing much less of that kind of spaghetti code, that gets jabbed all over the place. You just write one line in each of your functions that calls the engine to authorize that access. Right, so it's kind of batteries included. It does look simple, and I know a lot of people are starting to talk about this, so worth having a look at.
Yeah, absolutely. It sounds like a very interesting piece of technology, and it has like logic to express rules. So if you're a fan of that, that's going to be awesome.
Yeah.
If you're not, then maybe not so much. But I'll leave that in the middle. All right. So let's come to a takeaway here. Takeaway here is to encapsulate complex authorization logic for various reasons. First of all, you don't want to scatter this throughout the code for auditability. Second of all, it makes it clear and understandable. If somebody asks like, hey, what's your authorization policy? Bam, here it is. And third of all, you can actually unit test your authorization policy. You can write tests to ensure that your policy actually enforces what you think it should enforce. And then, of course, when your endpoints rely on that policy, they benefit from that altogether. So this one is really important. It's a really big one, and it's a very non-trivial item to tackle. But again, start by isolating pieces of code into a central class, and then maybe after that move to an external service or something like OSO with batteries included. All right. That kind of wraps up the authorization part. And that brings us to the second polling question that we're going to ask you right here, just to give you a kick under the table to make sure you're paying attention. So what authorization framework, library, or stack are you using?
Okay, so the results, that's surprising. I would have thought we would have had most people rolling their own. I guess most people are going to rely on the middleware. If you're writing an ASP net.core or Spring, that they've got that middleware built in.
Awesome. Yeah, the framework middleware is absolutely awesome. If you have, I would say, not too complicated authorization models or policies, and you want to rely on the propagation of certain permissions through a thing like tokens, ASP.NET is pretty good at that. Then you can very easily implement, and Spring has support for that as well, very easily implement authorization rules without having to write a bunch of code yourself. Absolutely awesome. All right, thank you for participating. Rolling ahead, and we got to speed up a bit. User authentication. Of course, only matters for clients that involve a user. Think about an app on a mobile phone. Honestly, we don't really care what the client is. We care who the user is, because 20 million people will have that app installed, at least if you have a popular app, and you'll have 20 million clients, but you don't really care to identify specific clients. You care to identify specific users. However, user authentication is a bit tricky because users are typically not very keen to authenticate on every request, because a user is going to authenticate once, like, hey, I'm Philippe, remember that, please. And that means that the client is going to include user's authentication state in every request. So once the user is authenticated, the client is going to include a piece of information that tells the API, like, yeah, that was the user, Philippe, from 10 minutes ago, from an hour ago, from 5 hours ago, whatever. How do you do that? Well, I'm going to go on thin ice here. I have a very unpopular opinion in the API world, and that is that the old way of dealing with user authentication state, sessions, still works quite well for web-based applications. If you're building a JavaScript front-end app, an Angular app, a React app, whatever, the browser knows how to handle cookies. Your API knows how to handle cookies because the frameworks typically do that quite well. And modern deployment options like Heroku have built-in support for running sessions, traditional sessions, on server-side deployments. They use Redis caches and all of that. They readily make that available for you. You can integrate that with Java sessions, and that brings us to a very important takeaway. If you're building a small-scale application, not something with millions and millions of users, but a small enterprise app with a few hundred users, and you don't need globalization with deployments all over the world, and you can actually manage that quite well in a server-side session, then my recommendation is to use that, because the security implications of keeping state on the server are absolutely awesome. That is the best way to keep state there. And pushing that state to the client with something like a JSON web token, for example, brings on a whole new range of security challenges that you'll have to address. And this is something that I know is not a popular opinion. I've included that because people often ask me when I talk about state management at a conference, they come back to me and they're like, yeah, we switched our entire old system to this new JSON web token based approach. And at the end, we were like, we didn't really gain anything with that, and we don't like it. And we should never have done that in the first place. And that's why I'm including that here. Still works for web-based clients, not for mobile apps and stuff like that, but for browser-based clients on small scale applications, perfectly fine. When you're not doing that, well, chances are you're building something a bit more advanced. Chances are you'll have other types of clients or a mix of clients. Then you're probably going to end up back at OAuth, like I said before. OAuth is kind of the de facto standard for handling these token-based authorization scenarios. So what OAuth basically offers you is the interactions between the client and the user and the authorization server, the tokens, the format of the tokens, and how you can handle that in practice. All right. Even in the world of OAuth, you would think that it's very clear-cut, like you do it like this, but OAuth is like, no. Here's a toolbox. Here's a whole bunch of options, and you just figure out which of these work for you. And even for the tokens that are issued here, the access tokens, there are two very specific options that you can choose in OAuth, which again confuses people quite a bit. One of the options is to issue a reference token. And that means that the client receives a reference token at the end of its flow with the authorization server. And a reference token is a long random ID. It has no meaning except that it points to state kept by that authorization server. So it kind of points to server-side state, but the client, as far as the client is concerned, it's called a token. And the client includes that in a request to the API. And to the API, that's still a random piece of junk. The API is like, I don't know what that means. It's a long identifier. What the hell do I do with this? Well, I go to the authorization server that issued it. I'm asking it like, hey, you gave out this token. Can you tell me what that means? And the authorization server will translate that into a set of claims that says like, oh yeah, that was for Philippe. He has these permissions. The token is, or the information is still valid, and so on and so on. And the API can now make a security decision. All right. Why would you want to use reference tokens? Any idea, Colin? You want to pitch in here?
Reference tokens, revocation.
Revocation. That is an absolute solid answer. If you want to kill a token, if you want to revoke a token, you can tell the authorization server that token 17, forget about that. And the next time an API goes back to that authorization server like, hey man, token 17, what does that mean? The authorization server is like, yeah, don't touch that, invalid, go away. And the API will reject access. Of course, revocation, better security properties comes at a massive hit here of performance, because now the API, every request to the API is typically going to result in a request to the authorization server. But this is what high security deployments are using, especially when you have the power to automatically revoke tokens. For example, if you have a fraud detection system that sees a request come in like, oh, hold on, why is Colin transferring? I'm kind of guessing here, but Colin doesn't transfer 25,000 euros every day. So why is he doing that today? And again, in 10 minutes, like that doesn't make sense. So probably there's something wrong. Let's revoke that token immediately to avoid any further abuse. That's what a reference token can do. In reality, this is not very common. In reality, people are like, yeah, especially that arrow from the API to the authorization server, people are like, we don't want to do that. With good reason sometimes, in most cases with good reason. So the alternative is using self-contained tokens. A self-contained token, typically in the format of a JSON web token, is an access token that contains all the data as part of that token. So when the client makes a request with that token, the API is just going to look at that token, make sure it's valid, that it's integrity protected, and then use the information in that token to make a security decision. And that's what middleware like Spring security middleware and ASP.NET, I think the identity layer, they have support for that built in so that you can basically verify the integrity of a JOT token, take out the permissions claim or the roles claim or whatever you're using, and then decide if something is allowed or not. Self-contained, stateless, often called stateless. Nobody has to keep track of those tokens, but revocation becomes a bit harder because you can't easily kill a token at the spot. So short token lifetimes come into play, and so on and so on. All right. What can I give you as a takeaway here? Analyze your security requirements, which is a very meaningless takeaway. I mean, try to understand what makes sense for you, because there's no one-size-fits-all solution. That's why I typically don't give answers in sessions like this or training sessions. I just give options with the pros and the cons, allowing you to make a decision for your system, because only you are the one that can make that decision. Self-contained, easy to use, but hard to revoke. Reference tokens, easy to revoke, but expensive to use with the performance overhead. So you can only make the right decision if you understand your requirements. That's what this comes down to. Awesome, Philippe, thank you for that information. What about handling that JSON web token? I read a lot about JSON web token vulnerabilities. Is that a big problem? I'm kind of paraphrasing some of the questions that you may have. Yes, JOT security is a nasty problem. No, we're not going to talk about that because I simply do not have the time for that. But the good news here is that I've written a blog post for these very fine gentlemen that they published on their website in December. And that blog post talks about 7 ways to avoid JOT security pitfalls. I really recommend you go there and read it because there's a whole bunch of very practical knowledge in there, including a bunch of tests that you should be writing for your API endpoints that accept JOT access tokens or JOT tokens in general, not specific to OAuth in this case. All right. Takeaway, religiously follow JOT security best practices. If you look at the article, there's actually a spec behind the article, or the article is somewhat loosely based on, and that's a JOT security best practices spec, which is really awesome. It's a nice RFC with 2 sections: problems, solutions. 1 is interesting, 2 is mandatory. Read that and apply the best practices listed there. And then finally, encapsulate your JOT security logic in a library, in a component that people can easily reuse. That's the way you avoid having similar implementations with potential vulnerabilities all over the application. Just have one reusable library and you're done with that. What do you think, Colin? Are we good? Can we dive into sensitive data exposure and mass assignment?
Yeah, we're good. I'm
or
just
do you have
wondering
some
if we don't want to just grab these 2 questions that we've got. So we got a question come in about any hints on how you can draw the line between when do you have to factor and upgrade your authorization to go to something like OPO and OSO. So when are things getting too complicated, and is there an easy way to kind of graduate and shift across, or do you have to do that all in one fell swoop?
Wow, that's a good question. Depends on how much control you have over the application. So let me tackle this in parts. When would you consider upgrading? I would say either if you're starting from a greenfield, if you know upfront, like we're going to have a pretty complex authorization model and we don't want to start writing this in code, then I would say try these things out and see what fits your scenario. And the other case is when things become unmanageable. You'll notice this when changing something introduces another issue in the policy, or when you're auditing the policy for the 7th time in 2 weeks or something like that. That basically means that something isn't working anymore and that you might want to look at alternatives. So you'll know when it's too complex. Doing everything in one go is probably going to be quite tricky. So you'll probably going to have to rely on kind of a hybrid approach. That's why I've been advocating to extrapolate or to extract the authorization logic into a class, like an authorization class in your system, because then you can gradually implement a new policy behind some of these operations before changing all the code on your API endpoints. So I would definitely recommend a gradual approach here.
Yeah, very good. Right, in the interest of time, let's move on to excessive data exposure.
Absolutely. And we have some time for Q&A at the end. Let's talk about the API security swag shop, for which I've not included the abbreviation, by the way. We have a list of online users. So apparently we 3 are online in the shop, and that's pretty awesome. Nice, right? Where does this information come from? Well, there's an API endpoint to collect online users, and there's a name of the user right there. And we insert that name into the Angular front end. Very easy, very nice piece of code, and we're pretty much done. This is quite common in a lot of applications. I've chosen not to include specific news stories, which I probably got from your newsletter anyway, in the interest of time. But this scenario is quite common, especially the red part here, exposing sensitive information, just like that. And that's what I want to talk about. Real world cases have resulted in account takeovers, in leaking private information like addresses here. It results in major problems. Basically, location information, that's the one I wanted to say. It resulted in leaking people's actual location. For example, if you have location-based dating apps, some of the API responses contain your physical location, which is, as you can imagine, kind of a nightmare when you're dealing with security. How does this happen? Well, let's look at a very non-beautiful code example. On top, you have a Java Spring endpoint that retrieves a list of online users from a user service, online 3, and it returns that list of users, online 4. That's it. I know there's no authorization here. That's not the point. I just wanted to keep things simple. Why are we exposing the user's address? Well, because the user list is a list of objects of the type user, and the type user is a class with, of course, the user properties, ID, name, address, and so on and so on. And we never expose JSON to the client. We never send JSON back to the client. We just tell Spring, in this case, like, hey man, here's a list of users, send that to the client. Oh, by the way, produces JSON, Spring automatically translates that information into JSON. And having a vulnerability like this is that simple. Returning an object with one field too much, and you have a problem. And something I really want to point out to the people doing manual or even automatic analysis of their APIs, this is something that does not jump out at you. If you look at the code on top, you have to know about this problem, so you can go into the users class and look at the fields that are present there. Otherwise, you are in trouble. So once you found it, how do you fix it? Well, the easy fix. There's an annotation in this case, JSON ignore, which does exactly what you think it does. It tells the JSON parser, Jackson, I think that is in the Spring ecosystem. It tells it like, yeah, ignore this field. Don't expose that. And that kind of solves the problem. I really don't like it. Why? It works, but again, it's like a positive model. Like everything is allowed except these things. And that means you have to go in to a class and explicitly add this annotation to every field you do not want to expose, which is not the best approach, I would say. And again, auditability is quite hard because you'll have to look at what are you exposing and how, which fields are there and which are ignored and so on and so on. It may be a better approach, a bit more verbose. Well, it's Java, so it doesn't matter too much verbosity, but having a DTO class, which is a very ancient pattern that still works quite well. What if we create a specific class called public user info? That is kind of a very useful meaning. It's going to be in a JSON.outbound package, at least if I'm building something, and it's going to tell the system what to expose. And we map our users onto this public user info object or class, which will only expose the ID field and the name field. And now you can look at your endpoints, like what are we returning? Oh, we're returning public user info. What fields are in there? These fields, nothing else. And there's no room for mistakes. Adding a field to the user class will not change anything. The only way to overexpose data is by explicitly writing the exposing code in this public user info class. And it makes it a lot harder to make mistakes and makes it a bit easier to audit your APIs. Takeaway, test your API endpoints directly. Why? Because, and I should skip back a slide here, because your client works as expected. If you give this client application the left part of the slide, let me skip back, sorry. If you give this client to your QA team, they're going to be like, yeah, everything is fine. This works. We only show the names, no sensitive data, but the data is still there in the network requests. So any attacker opening up something like Burp Suite to look at the actual requests and responses will see this data anyway. So that's why you have to test your API endpoints directly and look at what they return, not how the client handles the data. And as you can imagine, that's not a very fun process because you'll have to do this over and over and over again. If only there was a better way to handle this. Well, there is, and that's called OpenAPI contracts, and that's especially in combination with tool support for looking at APIs based on contracts. The definition you see here, I know it's not very pretty, but this explicitly defines what the response of this endpoint should be. It states on line 10 that the response, on line 8 that it's JSON, on line 10 that it's an array, on line 12 the content of that array, like, oh yeah, there's items with the type object, with properties ID 14 and name 17. And this leaves no confusion. This tells someone exactly what the API will return, and it also tells a tool, a security tool, exactly what is expected so it can compare that to the actual response. And that is how you automate your conformance scanning, as it was called in that very first poll. That's how you can use tools and contracts to ensure that your APIs are behaving the way they are supposed to be behaving instead of guessing or manually verifying that you don't expose too much information. And I'm sure Colin is going to be able to pitch in on this takeaway. So use OpenAPI definitions for security. It takes some getting used to write these. And yes, I have to look up the syntax every time I do because there's a lot of different options you can write everywhere. But once you get a hold of it, the hang of it, it really works quite well as a communication mechanism, as we talked about last time, but also to feed into security tools, into fuzzers, into all kinds of tools to basically ensure your API is behaving as it's supposed to be. Anything to add there, Colin?
No, I think so. I think it's a good time to put the next question up because it relates exactly to this point. You know, the OpenAPI spec is there to help you on a number of fronts, writing your code, generating stubs, generating mocks, whatever you want, but it also helps with security. And just the question there is for people on the webinar is, what things are you putting into your OpenAPI specs? Are you encapsulating your security constructs? Are you specifying authorization? The data contracts, we've just looked at excessive data exposure. Are you capturing that? Hopefully you're doing both. And hopefully it's not answer number 4. So pop your answers through on that solo. And then we'll take a look at the results.
Yeah, this is pretty much in line with what I see in practice. And I would say it's defining requests and responses is kind of the easiest way to get started. It's something that has to be done anyway. It's something that really matters for communication between teams, like the API people talking to the client, the front end people, like this is what you'll send us, this is what you get back, and so on. So yeah, for me, this is kind of in line with what I see in practice.
Yeah, absolutely. Right, mass assignment.
Yes, of course. Let's talk about how you can leverage those contracts to avoid mass assignment. So what's mass assignment really about? Well, again, a very beautiful endpoint here. In this case, an endpoint to update the user. And what we do is basically we have a patch request in this case. It goes to an endpoint/user with an ID, and it provides some JSON, or the client provides some JSON, which will basically be used to update the user. And in this case, the service uses the application uses the user service to update the user with that specific ID. Again, there should probably be some authorization there as well. And it provides that user object as the data, the fields to update. And the idea is that I can change my name in the application to Dr. Phil if I want to, which I kind of can because of my name and my PhD. So that's pretty, I don't know if that's awesome or not, but it's cheesy, back to the 90s TV joke here. That's a legitimate request. That's how things work out in practice. But if you look at the user data class on the left, you can kind of see that there's a potential problem, right? Well, first of all, there's going to be an ID field, but chances are that this update user doesn't use the ID, so it's not that big of an issue, or potentially not a big issue. But there's a role property. The role of a user used in this system with some homebrew authorization rules to decide how to make authorization decisions. And a malicious user can figure out that the role fields exist, maybe from other responses when it's exposed to the client for useful purposes, like modifying the UI based on the role. That's definitely useful. And the attacker can be like, hey, let me try to add this role field here and see if this actually goes through. And in this specific example, this would work. It would basically take the ID of the user, which is my user ID. It would take the user object with the name Philippe becomes admin and the role admin, take those fields, drop them in the database, override my user account, and now all of a sudden I've become admin. And this, I know when I explain this on a PowerPoint slide with these boxes, it's like, oh yeah, of course, like who does that? This is massive. It's everywhere. It's number 6 in the OWASP security top 10 for APIs, because this is a really, really common problem. And it's, as far as things go, invisible. The only way to find this is to actually understand how that update user function works, look at the data it accepts, look at the fields in that object, and then see if a client can, or if an API endpoint accepts that information. And that's as dangerous as they get. As in these invisible things, they don't jump out of you when you're doing an audit. You actually have to go look for them. So how do we fix that? Well, this is kind of a repeating story. We can add an annotation that says like, hey, JSON parser, you probably shouldn't allow someone to write this property. This is read only. Sure, you can do that. This works in practice, but again, you have to go through all your fields and mark each of them with this annotation, and forgetting one results in a massive problem in your application. So not the best approach, I would say. So the alternative, and you know how the story goes, you can use this DTO concept here as well. Why don't we define a update user info object, which we accept in the request on top on line number 2 at the end, you can see that, and we only define the fields that we actually want to accept. In this case, the name. Trying to give anything else will either get ignored. I don't know. I don't remember by heart what Spring does. Either it ignores those fields or it throws a nasty exception to say like, yeah, I can't parse that. I would have to look it up. I forgot. I haven't done Java in a while. But this basically solves that mass assignment problem, which is invisible. The takeaway here is that you have to test your APIs in their natural habitat, which means you have to actually run the API to make sure it behaves the way you think it does. Looking at the code is good, but mass assignment, I'm not very confident that your code analysis, unless you're like an absolute animal when looking at code for security issues, think it's very unlikely that this will pop up through a code analysis step. Runtime testing is necessary to get the full picture, because if you runtime test and you throw stuff at the API, things you know shouldn't be accepted, and the API is like, oh yeah, thank you, bam, done. then you know that you have found a mass assignment problem. That's the easier way to do this than code analysis. But hey, Philippe, isn't there a better way? Like, yes, there is. API contracts. Again, API contracts solve this problem by design because you define exactly what you expect as input. Like, oh yeah, by the way, in the path, there's an ID of the user, which is required, and it's an integer on line 10. And in the body, we have JSON content. We have a object with a property name, and that's the display name of the user. And this is a universally understandable definition of what the API is supposed to look like. And where can we use that? Well, first of all, for communication, that's one thing, but security tools can consume this. There's a bunch of tools out there, including 42 Crunch can rely on this, but you also have open source fuzzers that understand a tool like a schema like this and try to hammer your API with invalid data just to make sure that everything is rejected. So the takeaway, and that's maybe the most important takeaway of the whole data exposure and mass assignment topic, use OpenAPI definitions for security. Really, really important. Write them, get used to writing them, maybe auto-generate some code from them if you want to save time. That's also awesome. And then use security tools that know how to handle these things. And with that, I'm going to shut up. Thank you for
Thanks
listening.
very much. So just to round off on that point, the mass assignment and excessive data exposure is two of the categories that can be very well tested using security tools based around the OpenAPI specification. You know, it does work very well as long as you specified your data contracts correctly. So conscious that we only have a handful of minutes left, I'm going to ask people just to take a chance at asking some questions and grabbing that surprise gift that we have in store. I just noticed we missed a question in the chat there. Is a reference token the same as an opaque access token?
Yes.
Yeah,
so
they are.
Yeah, opaque token basically means a token that can't really be inspected without meaning. So yeah, a reference token is the official name for an opaque token, even though opaque token is often used. It just basically means the token is useless without introspection, which is a process where the API calls the authorization server to translate that ID or that reference token into claims. So yeah, it's the same concept.
Okay.
Great. Okay, folks. So I think in the interest of time before we get it cut off, just to remind you all, next month's final webinar in the series, we'll look at the outstanding other 5 issues in the API top 10. So again, we'll have a deep dive by Philippe and Colin to those. We're posting blog posts which cover a lot of the content that's covered in each of the webinars. We're posting those blogs on a regular basis on the 42crunch.com website. So please be sure to check that out. A couple of links below. Get on to the newsletter if you're not a subscriber already. Arguably the #1 API security newsletter in the industry today. We also have the #1 API, OpenAPI editor, which you get in your favorite marketplaces, 400,000 plus users already using it. And if you want to get a demo, don't be shy, just fill in the form on the site. We do have a prize hoodie giveaway this week. So that'll be going to Luis for his question. We'll be in touch with you directly, Luis. So congratulations for that. We'll make sure to get that hoodie to you over the next few weeks. So folks, make sure to check out the recording of the webinar, which will be sent to you into your inboxes in the next 48 hours. And until we see you all next time online, thanks, Philippe, and thanks, Colin. Goodbye.
Yeah, thanks for having me. This was really fun, and I hope to see you again in a couple of weeks, March 24th, to talk about the remaining top 5 issues.
Yeah, absolutely. Thanks, everybody.